Hey folks, I would like to show you an Ambic. Ambic is an Unreal Engine plugin that works alongside Wwise to handle ambient one-shot sounds. It's bound and spatially correct across the level, and it's designed to work with rooms and portals. You can spawn sound with 3 different spawning behaviors, which are spawn in radius around the listener, spawn in radius with physical material check, or at specific location using point tags. Those could be added directly into instanced meshes or hand painted. More on that later. You can modulate spawn behavior using any RTPC, something like wind or time of day directly affects how and when sound trigger. Let's take a look at working with Ambic in the editor. Here I have created a new Ambic sound collection containing only one sound. The sound will respawn continuously with a fixed 2 seconds delay. Ambic collection has a gameplay tag assigned. This is needed for the Ambic subsystem to be able to reference it. Let's activate the sound collection in-game using level blueprint. Once we hit play in the editor, you can see in the Ambic debug panel that the state is active and the sound is spawning around the listener. Ambic also includes a volume component as another method of state activation. It automatically sets the state based on the listener distance to the volume using the longest attenuation radius in the collection. Let's see that in action. As I start the game and run towards the volume, keep an eye on the Ambic debug panel. Once I'm close enough, the state will activate, and as I roll back, it will deactivate. You can have multiple sound collection active at the same time. Now before we get into spawning behaviors, let me quickly show how point tag works. We'll need them for the demos ahead. Point tags provide the Ambic subsystem with locations of meshes that are valid targets for ambient audio. For instanced and static meshes, we simply add a socket to the mesh named after our point tag, in my case audio Ambic point tree. Let's paint a few trees using Unreal Foliage tool. Now we need to collect the point data using the Ambic grid builder. This scans the level and stores everything into actors called Ambic spatial data volumes. As the word streams around the player, each volume automatically passes its point tags to the subsystem when loaded and cleans up when unloaded. With the Ambic script table tool, we can paint points manually. Here I will add a tag called audio Ambic point shoreline, choose the brush size and scatter distance, and then with individual clicks or mouse drag I can paint the points directly into the level. These are collected into a single editor-only actor. Then, in the Ambic script table tool, I can enable show volume content, which displays all the stored point tags in yellow. Notice that the hand paint points are shown in white. This means they haven't been stored yet. Let's regenerate the grid and you'll see them turn yellow as well. Now we can proceed with spawning behaviors. Since we are working with the point tags, let's create another ambient sound with a bird one shot. Select spawn at point tag, which means the sound will only spawn if there is a point tag with the correct gameplay tag within the spawn radius. Another spawning behavior is simply spawn in radius, which randomly pick location between the minimum and maximum distance around the listener. Finally, there is a spawn in radius with material trace, which has two modes. If no material is set, the sound perfors a trace below itself using the specified trace distance. If the trace hits a surface, the sounds will play. If nothing is hit, the sounds will not play. If a material is set, the sound compares the surface material below with the material specified in the ambient sound settings. This allows sounds to spawn only on specified surfaces. For example, if a cricket ambient sound should only play on grass, it will only spawn when the trace surface material is grass. Ambic sounds can also block spawning for specified Wwise states, such as an interior state. They can also be controlled by multiple RTPC values. RTPC values are defined using curves, which lets you modulate spawn probability and create smoother transition compared to using states alone. Ambic sounds can also modulate their minimum and maximum spawn times. These values can also be driven by RTPCs. For example, this can be used with a wind parameter. When the wind value is low, sounds spawn less frequently. As the wind value increases, the spawning rate also increases. And that's Ambic, a lightweight data-driven ambient system built for Unreal and Wwise. Spatial spawning, room and portal support, RTPC modulation, and full state control, all in one plugin. Thanks for watching, and feel free to reach out if you have any questions.